Okay, hello guys again. So today we're going to be looking at three problems that I found on the internet, and I found them actually very interesting. So today I'm just gonna be working through them and showing you how to solve them. So the first one, so for the first one, we have let S be the number of squares among the integers from 1 to 2013 to the sixth power. Let Q be the number of cubes among the same integers. Then A, S equals Q, B, 2S equals 3Q, C, 3S equals 2Q, D, S equals 2013Q, and E, S to the third equals Q to the second. So you can pause the video now if you want to try solving this problem. And okay, I'm gonna solve it now. So let S be the number of squares among the integers from 1 to 2013 to the sixth. So we have to find out how many squares are there from 1 to 2013 to the sixth power. So this is the first number that we can square, and this is the last number, right? So we have to find. So this is the last number in the set of numbers, right? But this is to the sixth power, which means we can take a square root. So that means that 1 to the 2013th to the 6th, right? That's the total number of numbers. But the total number of numbers that can be squared is 1 to the 2013th to the third, and then this squared. And so how I got that is there is the property of an exponent to an exponent, which means if I have x to the a to the b, then this equals x to the ab, right? So here what I did was the total number of numbers that can be squared is 1 to the 2013 to the third squared. So this means that 1 to 2013 to the third. These are all the numbers that can be squared because 2013 to the third squared equals that. So there are this many squares. I'm just going to write it right here. That's how many squares. So equals S. So I'm going to use a different color. So now let Q be the number of cubes. So the same idea here. So we have Q equals, and so here we still have 1 to the 2013 to the sixth, but this time we're taking the cube root, which means this over 3. So you get Q equals 1 to the 2013th to the second, all cubed. So that means that Q equals 2013 to the second, right? So now we can say, okay, then, so if S equals 2013 to the third, Q equals 2013 to the second, then we know that if we divide this 2013 to the third over 2013 to the second, we're going to get 2013 to the third minus 2, which is 2013 to the first, which is just 2013. So that means we know that S equals 2013 Q. So that means our answer is D. So yeah, next problem. So Vasya wrote down several consecutive integers. Which of the following could not be the percentage of odd numbers among them? So I'm going to give you guys if you can pause the video now if you want to try it. Yeah. Okay, I'll solve it now. So, which of the following could not be the percentage of odd numbers among them? So, I think here we should just use process of elimination. So, what we should say here is does 40 work? Can 40% be the total number of odd numbers? And the answer is yes. And here's why. So, this is basically the same as 3 over 5, right? Because it's 40 over 100. And so, yeah, you divide, what? Oh, sorry, my bad. It is not 3 over 5. It is 2 over 5. Eraser? Yeah. 2 over 5. My bad. 2 over 5. So, because you can divide both sides by 20, so that you get 2 and then 5, right? So, how do we know? So let's write we write 5 numbers. So the top number is the total number of odd, and this is the total number of numbers. So it's odd out of total, right? So if I was to say, okay, let's start with 2, 3, 4, 5, 6. So 3 and 5 are odd. That means that we have 2 out of 5, which is 40%. So 40% is actually a right answer. Or it is what it, how do I say this? That could be the percentage of odd numbers among it. So that's going to be ruled out. So for B, what you have to do here is you actually have to simplify it. So I'm actually going to erase all of this because that way we have more space. So for this so for this answer, we have to simplify it down, right? So this is going to be 45 over 100, which is going to be 9 over 20. And so the thing is that this actually doesn't work. So I'm not going to write actually. Actually, I should. So 9 out of 20 numbers, and that's not possible because it could be, okay, so if we start with 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So out of 20 numbers, here's the thing. No matter if you start with an odd or even, there's going to be 10 of each, right? Because you can divide it by 2. It's divisible by 2. So what's going to happen is there's going to actually be the same amount. So if I look here, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So 9 over 20 is actually not possible. So this is our answer. But now I'm just going to make sure. Okay, so I'm going to check with the other ones. So for 48, this is 48 over 100, which is equivalent to, if you simplify this down as much as you can, you're going to get, let's see, you get 12 over 25. And so this is possible. Here's why. So you have an odd number of numbers, which means that there is going to be one more of odd or even, right? So that means that this is possible because you can have one less odd number than an even number. So that means that we know that this cannot be an answer either. So let's check D. How about that? I mean, obviously we know our answer is B, but just to make sure, let's check everything else. So this is not an answer, this is not. B is 50%. And we know that I can literally just do this. 2, 3. 50% are odd. So that one's kind of obvious. But for the last one, this is the same as A. It's just reversed. 60% equals 3 out of 5. You have an odd number of numbers. And so you can basically do 1, 2, 3, 4, 5. And 1, 3, and 5 are odd, which is 3 out of 5. So B is the correct answer. So these are actually problems I find very interesting, and I like solving these. So, oh, I erased all of it. Oh, my. Well. Okay, so this is the one I found the most interesting, which is a book contains 30 stories, each starting on a new page. The lengths of the stories are 1, 2, 3, all the way till 30 pages. So every story has to be either 1, 2, 3, or 4, or 5, and each of the 30 stories has to be a different number of pages, but not necessarily in that order. The first story starts on the first page, page 1. What is the largest number of stories that can start on an odd numbered page? So you can pause the video if you want to solve this. Okay, so I'm gonna start doing it now. So let's use green. Okay, so the first one starts on 1. right? So that you can either count it out or you can use logic. And in this case, writing out 30 different stories, each going from 1 2 3 all the way till 30, that's going to leave you with like more than you're going to have to write like 300 numbers. So that's not going to be fun. So instead, what you can do is you can use logic. So here's how it works. They you have to use all 30 stories have to be a different number of pages from 1 till 30, but they don't have to be in that order. So here's one thing everyone should know is that if you have an even plus an odd number, that's always going to be an odd number. So if I have 2 plus 3, it's going to be 5, which is odd. So that's something we should remember. And so in this case, we should probably say, okay, well, the first one, let's just say it starts on page 1, right? And what we'll do here is we put every even number first. So all the even numbered stories will come first. So the first one starts on page 1, and it's going to be 2 pages long, right? Because that's the first one. So it starts on 3. And so that means we've used one even number, which is 2. And so that means that this story, then this story, right? So you're going to have 16 numbers, 16 stories that start on an odd number just using even numbers. So now we can say, okay, now let's use the odd numbers. So now we have 1, 3, 5, 7, 9, 11, 13, all of those. So, wait, yeah. So now what we can do is, so the 16th story, right? When you add an odd to an odd, that's going to be even. But when you add an even to an odd, you're going to get an odd. So when this starts on an odd, you add, because, when you use the even numbers, yeah, every number results in it. So the reason we have 16 here is because the first one starts on 2. The first one starts on an odd, and then the first story results in the second story. The first story, its length, results in the second story starting on an odd number. And I feel like this doesn't make sense, but in my head it does. Oh, that's a horrible excuse. Okay, but basically, what we can do is the 16th story. Well, actually, no, the 17th. No, this yeah, no, this the 16th. The 16th story starts on an odd. So now we have those 15 numbers, right? But only 7 of them are actually gonna make it um start on an odd number, and here's why. So since the 16th story starts on an odd, the first odd is gonna make it an even. And now you have 14 left. Now you have 14 odd numbers left. And so 7 of them are gonna make it 7 of them are going to make the story start on odd numbers. So that way we know that 7 of the odd numbers are gonna make the largest number of stories that start on an odd numbered page. So we can just use 16 plus 7 equals 23. So 23 is the final answer. So yeah, thanks for watching, listening, and yeah, thanks. Bye.